you very much for coming along again this evening. This evening we're very fortunate to have the Executive Director of Biodiversity for a Livable Climate. It's an organization here in Cambridge, but one that has nationwide, in fact international, reach in the people that it brings to its conferences and the people that it consults about restoring the climate to a reasonable state where humans can live in the long term. And he's going to share with us this evening, his name is Adam Sachs, going to share with us this evening some of the accomplishments of the program itself, but also the intentions for a conference that's coming up very shortly here in Cambridge. So I'll turn it over to Adam.
Thank you, Tim. I think we're starting with a little discussion of the conference. It's called Climate Reckoning, Paths to an Earth Restored. It will be at Harvard on November 17th through 19th. It's not a Harvard-sponsored event, but we have access to the facilities there at the Geological Lecture Hall on 24 Oxford Street. And it's a new kind of conference for us. We've done exactly 9 conferences since 2013, and actually that's November 2014. And we've looked at various aspects of eco-restoration and climate. We started with restoring ecosystems to reverse global warming. We've had conferences on oceans, on water cycles, on urban and suburban carbon farming, and we focused on those particular areas. With this conference, we're looking at the planet as a system. We're looking at the Earth system where everything is connected to everything else, and how you do that in a 2-day conference is a little bit challenging. We came up with the idea, we had no idea at the beginning how that would look. But as it turns out, we want to show the juxtaposition of different perspectives. So we have discussions about urban issues and food issues and wetlands and a variety of different topics. But they're not all grouped as a single topic. Everything is intermixed with everything else, which is the way systems work. It's everything connecting and collaborating in ways that are often hard to see, but have decided effects. The other part of a system that's really important to us and important in this conference is the concept of emergent properties. That is, these are properties that none of the components of a system have, but when you put them together, they take on a whole new life as the system as a whole. A simple example of that is you take oxygen, a gas, and you take hydrogen, a gas, and you put them together and you get water, a liquid. And it would be very difficult to predict the nature of the system from each of the elements, each of its component parts. We're looking at climate as essentially the Earth system. So if you have climate as conceived of as greenhouse gases warming the planet, you come up with a very specific set of solutions. If, on the other hand, you look at climate as a systems and interconnection problem, you come up with a very different set of solutions. So we look at climate as an eco-restoration problem, and that opens up a wide variety of possibilities for addressing global warming, not only in terms of global warming itself, but in terms of many ancillary issues that we face. So when you restore ecosystems, you address water problems, you address flooding and drought problems, you also address social problems, you address issues of food sovereignty and climate justice, and you do that because you are working with the whole system.
And the interconnection of that is seen very clearly by the way you posed it here. Do you think that desert occurs because of climate change? Think again. The biggest cause of climate change is land turning to desert.
And to give credit where it's due, that's not my poster. I think it came from Alan Savory, but it certainly speaks to the issues at hand.
And to the issues you've been looking at in terms of restoring ecosystems to a balance question, that is, restoring through biodiversity the entire system to one that stores carbon, not just releases it from the soils.
That's correct. So we have a series of slides, before and after slides, examples of eco-restoration excuse me, from around the world. And we have a pretty good idea of how to do this kind of transformation of land in various habitats. It's very low tech, it's very inexpensive, there are no untried technological forays going into unknown areas of putting particles in the atmosphere or finding ways to put carbon into the ground. So the first slide you saw was in Slovakia, and you see these erosion gullies and the bare land. And 9 months later, because of the way the water cycle is managed, the way rain is captured, you have a completely different situation. And there's even spontaneous generation of a dog. Well, not really, but
Same pizzeria in the background.
Same
you kind
pizzeria,
of
that's
see
right.
the landmark here on the horizon. But that whole ecosystem has been changed by the management of water and biodiversity.
so the mantra of water is slow it, spread it, sink it. When water lands on the earth, first of all, it should never hit bare soil because nature doesn't do that except in a true desert. The water would hit the leaves of the plants and slowly work its way into the soil, spread out, and go down. You'd have little, if any, runoff. You'd have little, if any, evaporation from the ground. Most evaporation happens through plants. And you wouldn't have flooding or drying out of the land because it's stored deep in the soils.
Well, let's take another example from another part of the world.
This is in Zimbabwe. This is on Alan Savory's Africa Center for Holistic Management. And it had been poorly grazed, overgrazed for decades. And this is what it looked like. And that circle is around a particular tree. It's called the elbow site. And grazing animals like cattle and other ruminants really has two faces. The face that we see in the American West is that of severe overgrazing, because animals are just left to roam on a plot of land and they constantly eat at the plants until the plants die. When nature does grazing, there are predators around, so the ruminants move in tight herds and they fertilize the ground as they go and then seek newer, greener pastures, as it were, giving the previously grazed pasture plenty of opportunity to regrow. And after 3 years of good grazing, holistic planned grazing, you can see that much life has returned. The seeds are just sitting and waiting. And when the animals come back to the site that they had grazed several months ago, they had already stirred up the soil, given the seeds an opportunity to sprout with whatever rain there is, and having the nourishment that they require from the animals grazing, the land is now ready to return to abundance. So
that's just been 3 years flat. You can see the same tree involved here circled in this example in 2006. There it is in 2009. sort of surrounded by oceans of grasses starting to sort of re-anchor themselves in the soil.
That's right. And the first grasses that show up are annuals, but annuals eventually pave the way for, well, pave the way is really the wrong way to put it, but create a path for the perennials to grow. The perennials grow with much deeper roots, which allows water to infiltrate into the soil and can completely change the ecosystem. And we'll see more examples of that.
Take Mexico.
Here's Mexico. This is a man-made pond that a rancher created, bulldozed for his animals. And after a while, he began to realize that there was a better way to do it. And so he began restoring to the land to health because there was relatively little rainfall on this site, and rainfall makes the major difference in how fast a site recovers. But because there was so little rainfall, it took 25 years. However, there is about 6 times as much water in the ground in this picture as there was in the pond in the previous picture. And it's feeding and nourishing and watering the animals on its own now that it is returned to health. Here's a front yard. It was 90 degrees out on a late spring day, and I used to live in this house, and I took my high-tech little kitchen thermometer and measured the temperature from under the bushes all the way across the lawn to the asphalt of the road. And I often ask this question of people, and you folks out there can't give me an answer real time, but I ask, what do you think is the difference in degrees Fahrenheit between the warmest and the coolest spot in that picture, the warmest spot being the asphalt and the coolest being under the bushes? And it turns out that it was 60 degrees Fahrenheit. And that's all about water and ground cover and how they work to cool the biosphere, to cool the places on Earth where most of the life is. And we can do this in many places. Even with elevated greenhouse gases, we can do a lot to cool the biosphere while we're doing other things to pull carbon, excess carbon, out of the atmosphere. Here's an example from India. Rajendra Singh is known as the Waterman of India. In 1985, he was working with communities to restore the rivers by creating these little catchment areas for water. And you can see in 15 years, the river returned to the scene. And he has helped over 1,000 villages recover their water. And at the beginning, the villages were losing their young people. They were unable to farm because of the drought, which is an increasingly common problem. And as the water came back, the people came back to the villages and were able to reestablish their farming and their earning a living without having to go to cities, which are often very difficult and unhealthy places, as we know. Now here's an example from Elko, Nevada. It's Suzie Creek, and this is a restoration site that was created by a couple of our speakers in our 2015 Restoring Water Conference, John Griggs and Carol Evans. John is a rancher. Carol is a fisheries biologist. She used to work for the Bureau of Land Management. Carol wanted the fish to return to the Great Basin, and John needed more grass and more water for his animals. So they started doing holistic planned grazing. Nevada used to be a grassland, not a desert. And they worked on the restoration of the property for about 15 years. And then beavers just showed up. And they, of course, are nature's master hydrological engineers. And after 15 years of the good grazing management and another 10 years of beavers, Suzie Creek looks like this. And that's after 4 years of drought. The other ranchers in the area are having to move water in tank trucks, but John has plenty of water for his animals, along with grasses for them to feed on. Now, if we can do this in Nevada on less than 10 inches of rain a year, we can do it just about everywhere. Here's another example. Michael Kravchek is a hydrologist, an innovative hydrologist from Slovakia. The first two slides were examples from Michael. And this is an example of a Mexican site. And you can see that tree, the arrow pointing to that tree. The technique is essentially to put either rocks or logs across a flowing water source, and to transform the nature of the flow from flash flooding into water spreading out and sinking into the ground. And when you do that, it transforms its habitat. And this is the same site 2 years later.
It's pretty extraordinary. I love these landmarks of the trees here. You can see straight up, there it is, without any effort to manage the flow through the water. And by obstructing the water, getting it to seep into the ground, you get a very different outcome with the ability to capture even more water. It becomes a positive feedback loop in a way, where it becomes a sponge for any water that falls into the system or tries to run through it. You can't run a stream through that very quickly because of all the biomass that's going to get its absorptive roots right out there to pick up all the water on the way through. It's an extraordinary set of examples you brought here. Who is coming to the forthcoming conference that is going to talk further in this vein?
Well, I would suggest that people go to our conference website and check out our speakers. We have some extraordinary people, and it's a wide variety of people from different backgrounds looking at how each ecosystem can contribute to the recovery of the whole and to the, we like to say, reversing global warming. Of course, it's not like putting a car into reverse and going backwards, but it is putting a process that is destructive in a much better situation so that it works. So we have speakers. A couple are David Johnson, who is a microbiologist and an agricultural researcher at New Mexico State University. And David has come up with an approach to managing compost where he takes into consideration the fungal bacterial ratios, which are critical in the way a soil functions. So with nitrogen fertilizers, we kill off a lot of the fungi and we have an overabundance of bacteria. With David's process of composting carefully so that he does not break the fungal roots, the mycorrhizae, he gets dramatically different results in terms of the growth and productivity of the land. Now, he's working in the high plains of New Mexico, which is not by any means the most friendly area for farming, and he gets extraordinary results. Results that are so good that at this point he's having difficulty getting published because conventional farming science doesn't believe it. And so he's working on having confirmation of his results from other sources. David will be there. We have Joan Maloof, who is an old growth forest specialist and an author. We have Herbert Dreisaitl, who is visiting at Harvard this year, and he's an expert on urban land restoration. And about 19 other speakers who I think you will enjoy. One of them provided us with these slides. Her name is Frédérique Apfel-Marglin. She is an anthropologist, professor emerita from Smith College. And for 20 years, she's been in the Amazon and the Peruvian Amazon with some indigenous communities that she's worked closely with. And around 7 years ago, she learned about biochar. And it turns out that in these communities, there are some very fertile areas of land, and there are areas that are pretty barren. And the reason for that is that hundreds of years ago, the fertile areas had been treated with biochar, which is a combustion product of biomass that provides a lot of area, surface area, for microbes and fungi and water, so that it contributes significantly to the fertility of the land that it's in. The knowledge of how to make biochar had been lost, and she brought it back to these Amazonian villages. And here's an example of soil that had been bare and had a crust on it so that water couldn't get in. And people took very low-tech materials and started poking holes in it so that it would be jump-started, and put in biochar and planted their gardens. And the next season, it looked like that. Early in the season, later on in the season, it looked even more dramatic. So this is what we can do with land management. It's very low tech. It's not that difficult to learn, although to be an expert certainly takes a long time, like any expertise would. And all of this can turn around our careening our careening climate ship in dramatic ways.
Especially in urban areas. And we spend a lot of time in urban areas thinking of floodwaters as something you got to get rid of as fast as possible, like putting it down the drain and out to the harbor. But in fact, one of the problems is that there's too much impermeable surface. And I gather one of the efforts now is to depave Massachusetts, to bring back the urban soils.
This is an effort that started in Somerville, and the city donates a dumpster, and a contractor will volunteer and come in and help, and people will cut up the asphalt on a homeowner's driveway or backyard when they no longer want it. And in the middle picture, there they are after the effort, and in the bottom picture, this is what it looks like a year later. Now, the land recovers pretty quickly in Massachusetts because we get approximately 45 inches of rain a year. In other places, it might take longer. Another thing an urban area can do is create rain gardens so that the water, which normally flows off the street and into the gutters, instead flows in the other direction onto what would have been a sidewalk area, but is now a rain garden. The water sinks into the ground, the plants grow, and you stave off considerable flooding problems and expense.
Well, you definitely want to come along to Adam's conference coming up here. And remember that you can sign up for it, in fact, to learn a heck of a lot about these things in November, later in November from the 17th to the 19th. You can see the website there for registering and get in touch. This is, in fact, a very promising means of a new kind of collaboration between citizens and scientists. Thank you very much, Adam, for coming along.
Thank you, Tim.